I have sufficient maybe friendly. I'm not they don't exactly know because I wouldn't be willing to bet any kind of money at that. I'm really more worried about what actually help.
There it is. Great. All right. We're getting there. It's about that time. We're probably going to have plenty of time in this session, as you can tell. Richard did put together a lot of slides there at the end, so we'll see how it goes. So hey, this is the MLS working group. It's Friday morning, so if you don't have any place to go, feel free to stay. Just don't be disruptive. Yeah, bye by the note well. Which brings us to the next thing, the note well. It's Friday morning. You should have seen this already a bunch of times, but basically, if you're here, you're going to participate. You're going to follow the IT processing rules. There's stuff about IPR. If you know things about patents and the like, and you're here, you're supposed to disclose them. You will be recorded. Please be nice and all that good stuff. If you want some more information, there's a bunch of BCPs up there and a bunch of links. You can read them. Sorry, I'm Sean Turner. This is Nick Sullivan. We're the chairs. Requests, minute takers. I think I know like almost everyone in this room, so hopefully someone will volunteer before I pick them. Going once, going twice. Anybody? 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 And, I thought you were going to the microphone. I was like, that was going to be awesome. Joe Hall. You got to leave. Joe Salloway. You were next, Colin. Stephen Farrell, would you do it? No. Really? You got a thing too? I don't know. Come on, Matt. Matt, thank you very much. Jabberscribe. All right, cool. Only 6 times the charm. Jabberscribe. Is anybody in the Jabber room? I'll be the Jabberscribe. All right, thank you very much, DKG. The blue sheets are going around. Please sign them. When you're at the microphone, please state your name. Basically, that's for the minute takers. Try to speak as, not too quick of a cadence. I have the same problem. Some others do as well. Let's keep it professional at the mic. This working group has not suffered that problem recently, or ever, actually. So thank you very much. Our agenda, we canceled Thursday. We have a very intimate group here on Friday. Basically, what we're going to talk through is administrivia. Britta has some user authentication within groups that she wants to talk about. And then Richard, I guess it's just Richard and Raphael's not here, has a bunch of, and Benjamin are going to talk about the protocol. And they have a lot of slides. So while this looks a little late, there's a chance that we might actually go the full 2 hours based on the number of slides. And then at the end, we're going to try to figure out what we might do at the next interim. Is there anything else that we need to put on the agenda?
Just one item. If you could speak closer to the mic, thank you.
I can do that. Thank you. All right. Without much further ado, then, Britta, you're up. There's like some quirky way to do this, and you can give her that, and she has the power. All right.
Okay, so I'm going to get straight to the point and give you the motivation for all of this afterward. This is about getting user authentication within the group. Right now, as it stands in the current spec, we have essentially that we can trust the signature keys. If you can trust the signature keys, you can get authentication. And what do we do if not is an open question. So this is about, okay, well, maybe we need to start considering that next step. To get straight to the point, in case you can get lost in the motivation along the way, I'm essentially proposing that we need to consider adding one more extra key derivation inside here that will be used for the key authentication, if we get to that, like if we actually want to allow authentication. Okay, so let's get the motivation behind all this. So this work, or this question, comes out of a project that I've been working on with Benjamin Dowling on the authentication of the Signal protocol. And I don't want to get into the issues that we've found there. There's a number of them, but more of how they do it and the fixes we found, because if we're going to be proactive in MLS to not have issues, then maybe we should consider those. So in Signal, we use a QR code or numeric comparison, and these are essentially computed over the long-term keys as a short version. So computed over the long-term keys, they're static. The user can cross-compare them or do the QR code verification. What this doesn't allow is epoch-level authentication. So in terms of MLS or in other protocols that are dealing with or hoping to deal with post-compromise security, this doesn't meet the requirement. Essentially, if you compromise the user, you've lost everything. And this is even more particular when you allow things like this user-to-user authentication. Now, this seems like it's on the API level, but the fix that we found is that if you had derived a key actually in the key exchange that can be exported, that's separate from all other keys, you can get this better. That you can actually get an epoch-level authentication, so the users cross-compare, say QR codes at some point, then we actually have not only authentication for who we were talking to at the beginning, but all the epochs previously. Now, yes, I see you, Ecker, but hold on one second.
Sure, no, please.
Now, if we don't have this and only have the user level, like at the beginning, you say, all right, we're only talking about identity keys. We have a sort of deniability, but in reality, that doesn't give us anything. Like if we're only relying on those for any sort of authentication, then we're not even getting the basic level authentication, like if we do a user cross compare. Go for it.
Yeah, I'm just trying to make sure I understand the security property we're trying to achieve here.
Mhm.
And maybe you're going to get to this, in which case tell me to sit down. But so in Signal, it's straightforward because there are only two participants, right? But in MLS, when there are n participants, are we trying to ensure that A cannot pretend to be B to C, or are we merely trying to ensure that that attacker cannot pretend to be a group member?
An attacker.
Thank you.
Yeah. So, which actually we'll get to right at the end, because there could be both cases if we consider it. But really I'm talking about if an attacker comes in from outside the group. So if we can say here within a group, we'll do a cross comparison. So how this sort of works, just a quick fix, if we were looking at Signal, of course this depends on how you implement MLS, but if we're looking at Signal, this is saying, well, we could just compute these like QR codes or the numeric comparison in a way that's epoch specific. I'll take the question.
Sure, very, very quick. What do you mean by an epoch?
So like within MLS, it would be like whatever the current group is, and then when we send an update, that'll be a new group, and that'll be a new epoch.
Sorry, Joe.
Or not new group, new epoch. So, big picture. What we're coming out within the terms of security modeling, this is for Signal. If you do not do this, then essentially you get red check marks right across the front of this cross comparison with depending on what you compromise, or you compromise a device or user, or if you have an eavesdropper on this channel. What can be achieved, hence the achievable guarantees, depends on what keys you're pulling and when and how you cross compare. Now these are not achievable, as I said, if we don't have something derived from the current epoch, if it's only a general static state. So in terms of MLS, that brings us back to this picture. Now this, again, is group level, so you'd be pulling a key within a group and you would only cross-compare within the group. And if you think of a bunch of users, that might not be realistic overall, that you always want to cross-compare only one group at a time. So we kind of begin to go into the, should we allow epoch only or group only motivation? If we do group, this kind of, again, goes towards the API, and that's out of our scope. But if we're going to allow that eventually for some applications, we need to be allowing them to derive the keys now at this level within the protocol. That's the motivation. So if we have for a group, that means deriving from related to the group context, as I pointed out. here's the question from that Ecker was saying, what about if it's an entity within the group? Well, yeah, we could derive from the signature key. But as I mentioned at the beginning, if we're talking about deriving some sort of authentication key from the signature key, we're running into issues similar to Signal, in which case you're not actually getting any authentication in terms of MLS goals of post-compromise security or forward secrecy type within user authentication. However, there is a fix for this as well, which actually came up at the last interim, that if we allow ratcheting for signature keys, and there was a motivation for that, that is outside of this context, but if we are going to allow ratcheting for signature keys, we can get around this issue. So basically, our situation comes down to a few variants of what we can choose. We can say outside the scope of MLS at all, in which case we basically say you have to trust the signature key permanently as a static signature key, which we're not even doing for regular keys. Or we can say, yes, we're going to ratchet the signature key and allow user authentication within that, in which case we don't even have to derive an authentication key separately. Or we can say maybe within the groups that we're going to allow derivation of an authentication key. So there's a few options here, and it's a bit of choosing which direction to go. I would definitely say that if we're going to allow for the maximum flexibility, we should probably be allowing for derivation of these group level keys as an option at the very least. Any questions or comments?
Hi, Daniel Kahn Gilmore, ACLU. So I appreciate all the thought that's gone into this. And I'm having a little bit of trouble getting my head around what the expected user experience is of doing this kind of verification. So maybe can we zoom out from the protocol details for a second and talk about what sort of cadence we expect users to play the QR code scanning game at? And like, do we have any evidence that users are interested in doing anything like that?
Well, I mean, you've got some users are interested at least. I mean, we've seen that already with various Signal and the other applications of it, that some of us actually do like to compare QR codes or numeric comparison, trying to know who we're talking to, right? So we have some motivation at some level. Now, we could say, no, we're going to trust only the server to verify these signature keys. Okay, then we don't need to involve the user into this experience. If we're going to say, no, we want to allow deniability and get around this in some other way where this users can cross-compare afterward, sure, not everyone's going to care about that, but someone is. And if we do that, can we allow it so that you maybe only have to do it once? Or when you do it, you get verification for all previous communication, that you know that you've been talking to the same person the whole time? There's various ways.
Yeah, I think this gets to my question as well, which I'm trying to figure out what guidance we give the user. So you say like, great, using MLS, outstanding. What do we tell them about what you want to do to be safe using MLS if you're concerned about compromise? I think maybe this is a separate question. It sounds like the mechanism of proposing is actually very straightforward for the protocol. So like maybe we can like deal with that problem later. But I think it will be important if we add this to the protocol. And if we say, if all we do is like add a new like authentication, like a new derivation stage, fine. But if we like actually have to material in the protocol about authentication codes or whatever you want to call them, then that has to come, I think, with some guidance about how you would use that mechanism. And so I guess if you give any thought to like what you would say, like if as a user of this protocol, how I have to behave.
Oh, sure, yeah, I can definitely give this way of saying here's to verify users if you want to do a cross comparison with QR codes and how to do that correctly. That's what we've been seeing out of the Signal analysis, is that there's actually a correct way to do that in a way that breaks basically everything. So yeah, we can give that if we want to give that recommendation. It seemed a little bit outside the MLS protocol scope, but
I actually more meant how often I have to do it.
Currently, if we do a user-to-user compare, we can say that if you do it once, you can verify for all previous epochs. There is some work being discussed at the moment of how you can do it once and then rely on an untrusted server to actually keep being able to compare it after you've done the one user-to-user comparison. So there may be some possibilities coming forward.
Thank you.
Joe Hall, CDT. I'm going to dissent from the past two comments and say I'm not as concerned about user level issues here, like with group conversations and Signal right now, with static, identity, it's very, very hard to, cabin the group membership in a way that using like the equivalent of safety numbers, you can kind of bootstrap that kind of thing. And you probably know way more about this in practice than I do.
I didn't quite hear the last two sentences very well. Can you get a little closer
Sure,
to
I'm
my
just saying,
thinking?
like, one of the things that I've been trying to do is even though the Signal app, for example, does not support any kind of mutual verification in the user interface for groups, right? We've been looking at ways to sort of like ad hoc that, right? And using the safety numbers, essentially create things that look like a safety number with n sub keys in it, right? Not sub keys, but the chunk of the numerical thing in it. So it gets as big as many group members as you have, right?
Right.
Every time you got a new group. But right now, that's not really supported at all, and for good reason, because it's really messy. And
Yeah.
so while I understand we want to think about what we might say about users, I'm more persuaded by what you're talking about in terms of making sure that we meet the security properties, and then it's going to take a lot of work to talk to users. And so I just want to say that maybe we should think about it, but not sort of design specifically towards it. Anyway.
It's sort of about allowing the option, because if we don't allow it now, then we're going to run into it. You're absolutely right about that. If I want to say, if I'm going to do a group level key, authentication key derivation, and then cross compare that with some user and we have in shared groups, then that's going to be a log comparison. Now I could get around that with ratcheting the signature key. So that's going to be a lot easier in many ways, but there's challenges there too, so.
Yeah, now one of the things you said in that last comment sounds interesting, like we're taking the.
Can you get a little closer to the mic?
Yes, sure, sorry, Richard Barnes. Yeah, this idea of taking the set of groups in which two devices or users overlap and making that one comparison sounds appealing. That's probably a little bit beyond the scope of what we're talking about here, because we've been operating on a group level. Trying to understand the protocol impact here. Is the proposal here basically to generate some new stuff off of the key schedule that would go into this comparison? Maybe you could I may have misunderstood something on previous slide. Maybe you could kind of elaborate like what the thing is that we would generate and how that would be validated in the comparison.
So going back to key schedule, that's basically what I'm saying is if we want to have a group level authentication, so there's different, like if we're going to allow authentication for all the groups that you're in, or if it's just, I know that who the user is. Those are different questions. It depends on if you want to say the group level key or a signature key. So there's a choice issue. If we want to allow the group level, then all I'm suggesting is, derive one more key here. So we have a derived secret for the handshake, etc. We'll have one for, we could call it authentication key. So for the actual protocol impact of that, it's one more derivation.
And that would, the thing we'd get out of that, if say you and I compare these codes, we would compare them just for equality?
It's essentially that, so here's the options that we were finding with Signal. That if you don't do this, then the only way to talk about current epochs that we're in is by using keys, such as the group key, which means that you will necessarily have to keep at least 2 keys in memory from previous epochs. Okay, so now we're kind of violating forward secrecy. So if we're wanting to get around that, then we want to derive an authentication key that's separate.
Sure. Yeah. No. I'm just
Or maybe I didn't understand the question.
Understand the ceremony here. Like, so that I show your device a QR code. That QR code encodes the thing we have derived off the key schedule here. Is your device, when it receives that, just checking that it is the same as the thing it derives off the key schedule for this epoch?
So if we're comparing devices, we both have to be able to derive the same authentication key, unless you're dealing with signatures, which gets into ratcheting signatures. To cross-compare, what we found is that you need to have a essentially mismatch between the devices. So the 2 QR codes cannot be the same. That's a very important, actually. And so the background within the protocol, that's okay. It's okay if I have scanned your QR code and it's simply computed that we have the same authentication key. Let me go down to the slide, so. Here. So for example, if we have the same authentication key that's coming from the group, so we both know it, and we just have different roles, this could be identities as well. So long as that's going into the computation and there's a disconnect there, now we can both compute it, but what's coming out invisible to the user, it's important that there's a mismatch. So for us, it would be cross-comparing the QR codes.
Okay, and then the thing that you and I get out of this,
Mhm.
at the, if the
If we
verification
do
works-
it, then we get authentication that I have been talking to you for the current epoch and all the past epochs, at the beginning of time, including the initial
Well,
setup.
So in a signal one-to-one case, I think I agree. I'm
Mhm.
curious what properties you get in a multi-party case where we're in the group. I think, if I understand correctly what you're proposing, the property you get is that you and I have the same view of the group and have
It's the
for
same
all
view of the
previous
group, yes.
epochs.
Yeah,
Okay.
it's the same view of how it works. Uh-huh.
Yeah, I mean, this seems useful. I mean, I'd be glad to take a look at a PR for this. Actually, one more question.
Yeah.
One thing some of these authors have been discussing is doing kind of an exporter roll off the keychain. So like in TLS, we have, there's an exporter secret that's generated, which is used to develop other things that you're going to
Yeah.
need to.
Something like that could work
Could we
here.
route something, could something like this sit on top of, if we made kind of an off ramp from the key schedule from which you could derive other stuff, could something like this sit on the other side of that off ramp?
Yes, absolutely. I think if you're going per epoch that you've got your off ramp, then yeah, absolutely. That's exactly the sort of motivation here, is that you're pulling off something that's not going to be related to the group context at all, aside from derivation. That's a random relation.
Yeah, in that case, it might be useful to write this up as its own internet draft, as kind of how you do kind of external authentication of an MLS session. Because once you've got that cut point, you can say, grab the exporter, derive the authentication key, and
Yeah, something like that would work.
So,
Would
yeah,
work
I
fine.
think we could look at this as a PR, but it might be a little bit cleaner to do as a separate idea.
Okay.
Either way, it seems like it provides some value.
All right. Thank you very much, Britta. All righty. Now we have Benjamin and Richard. Oops, sorry. All right. Which one of you wants to go first? You're supposed to go first. Do you need to step out? All right, fair enough.
Looks like not yet. So
Okay.
if I get the ping, I'll run out of here.
Okay, we'll do a swap.
Benjamin can take over. So this is about the protocol draft, which is probably why most of you are here. This is all the interesting stuff. So basically the overall structure here, we've got like 45 slides or something that's going to be split between me and Benjamin. We've got a review of what's been happening lately since the last interim meeting, and then we've got a bunch of ideas which due to not getting things done in advance don't have PRs to go with them, but we've tried to explain them clearly in the slides here and to get feedback so that we can then have some PRs in the next few weeks and have some discussion on the list about in what form we should land these. So right now we're just going to be talking about kind of directions. We've tried to characterize the trade-offs and protocol impacts of these various proposals to try and get a sense of the group of whether the trade-offs seem worthwhile in these various cases. So going back through the history of the last couple of versions, I think our objective was to have draft 06 as a plausible version for analysis Actually, no, our objective was to have 05, I think, as an analysis target, and we discovered that we had some bugs in it that made it unimplementable and thus, difficult to analyze. So we spun a draft 06 after the interim that incorporated the bug fixes and a couple of ideas that came up at the interim. So there's some terminology changes. There's some bug fixes to the key schedule. I think the big thing, we made a big change in draft 05 to introduce this common framing layer. Where we have a common encryption and signing layer that's used for both handshake messages and application content. And in the process of introducing that, it affected the transcript computations, and we just screwed up that translation. And so I think it's implementable now. I think we may have more than one implementation at this point. So we fixed that in 06. And then did this reordering of blanking and update in remove that Karthik noticed was causing unnecessary breakage, unnecessary fragmentation in the tree. So that gets us a little bit more. We The general rule in MLS is that the more blank nodes you have in the tree, the less efficient your operations are. So we generally try and keep the tree more completely populated and a few less blanks so that things stay more efficient. This change maintains that efficiency. So draft 06, I think, is the major analysis target now. And our focus in 07 was doing optimizations that make the protocol work better, but don't really affect the security analysis. So I think that first bullet may actually be wrong. I need to check the PRs, but we had a few more bug fixes here. An implementer noticed that if you encrypt the add message, then the welcome message that's provided to the new joiner wouldn't enable them to decrypt the add, which they also need to join the group. So you couldn't actually add someone to the group while encrypting handshake messages. So again, yet another bug fix. Good to find those. Was one we've found in several cases here that having implementers have helped us find these sorts of things. The biggest thing we landed was this tree-based application key derivation, which Joel Alwyn did a lot of work on and presented at the interim. I'll talk about that a little bit more in the next couple slides. In that same PR, we introduced some rules about consuming secrets. Where one of the things, if you've got a hash-based ratchet, say, where you're moving things forward in time as you receive messages, you want to make sure you delete things so that you get forward secrecy as you move that ratchet forward. And so Joel came up with a very nice phrasing for how the rules you should apply to make it the maximum forward secrecy you can in that framework. We also had an init message, which is kind of a summary.
Richard, before you go on, so the top bullet, if you haven't done it, you're thinking about doing it because of the interim. That's where Karthik or Cass, I can't remember which, said if we don't do this, then we don't get some of the properties that we think we're getting. Right?
Yeah, I think it has been done.
Okay,
yeah.
good. I just wanted to make sure we didn't blow it off.
Yeah, I think it was more. Yeah.
All right. Thanks.
So just to overview this application secret tree stuff. Right, when you update into a new epoch, you generate a new application secret, which is the thing you're going to use for generating encryption keys for the whole group. And you're going to KDF off of that individual secrets for the members of the group, which sit at the leaves of this tree. You might notice this is the same tree structure we're using for the ratchet tree, right, for encrypting stuff to the group. But I kind of feel like that tree tends to move bottom up in terms of generating secrets up the tree. This one moves top down, and we seed it with an application secret, and then we KDF down the tree. So when we start a new epoch, we populate the root node of this tree, and that's all we need to do. There's in earlier versions, you had to do a linear size number of KDFs as soon as you updated the epoch, so you could receive from somewhere as soon as you received in order to get forward secrecy. But right now, all you need to do is generate that application secret. And then when you receive from someone, you generate KDFs down the tree to get that person's leaf key, which is going to end up producing it'll be the starting point of their hash ratchet from which you'll get encryption keys. And the point here is that instead of doing a linear size number of KDFs to get forward secrecy when you start receiving, you've had to do only a log number here, and you've only had to keep around a log size number of other keys that you need to generate the other secrets. So I guess I should have highlighted the status quo ante, but before you would have had to generate all of these leaf secrets to get forward secrecy in this context, whereas here you just have to keep around these dark outlined secrets. So that's kind of and the idea is then, if say L were to send something next, you would, KDF down from this point and keep around some of these other nodes. So you gradually build up to where you have all the leaves populated if everyone sends, but you only generate when someone sends a message into the group. And so you have you react a little better, a little more conservatively. You don't do as much work up front. Wanted to also highlight this consumption. Oh yeah, Benjamin.
Isn't there a typo on the previous one? F shouldn't be populated.
Yes, you're right. F should be.
Is that the case in the thing we put in the draft? I don't remember.
I think the draft is correct. I think this is just my hand generation of the slide that's screwed up. This working group requires a lot of artistic skills. Sometimes, things fall through the cracks. The other thing I wanted to highlight here from draft 07 was this consumption rule. The rule here is that a secret is consumed if it is used to decrypt a message. So in this example, we've received the second message encrypted with the second generation of keys from E. And to tolerate reordering, we want to keep around the keys from the first generation so that if that first generation message shows up, we can decrypt it. But by these consumption rules, we've had to delete this key and nonce. We'll delete these as soon as we have decrypted the message, because now they're no longer needed, because we should never get a second generation message. And the second rule here is that if we consume a secret derived from a secret, then we have to consume that secret as well. So basically this consumption rule back propagates. So when we decrypted this generation 2 message here, we now have to consume this secret, this secret, this secret, and so on up the chain. And so you can kind of see how this leads to forward secrecy, because now you've deleted anything that could possibly be used to regenerate the secret you just used. So if there's compromise from this point forward, then you can't go back. You can't reconstruct the stuff you just used. Yeah.
I have a question about that. My expectation is that when you derive key and N, not when you consume them, you will kill the secret that generated them. So to me, it's like the last cross here. You erase that secret as soon as you derive KN and the next secret, so that you never have any problem in case that secret gets leaked.
So you're saying, like, if we got a generation 3 message here, we would immediately derive K and N from this secret and then ratchet down one more step.
Ratchet and kill.
Yeah.
Like basically, I see it as a one step, like 2 derivations. The next application secret, the key, the nonce, and you kill immediately the secret that generated them. Because otherwise, you lose that nice property that you don't you never can recompute that key.
Mm-hmm.
So I think we discussed this.
Yeah, you and I have discussed this often. I don't think it's super clear in the document right now. It doesn't follow from these 2 rules we have, so it might be useful to clarify that.
My expectation is that as soon as we derive the keys, we should delete the secret. We will never use it anymore.
Oh, I thought that was coming from Ecker. So yeah, and one thing I guess I should have clarified on this slide, that once a secret is consumed, you have to delete it.
Riyad Wabi,
Yeah.
quick question. Would it make sense to just define an API that, for example, takes the leaf node there and returns KN and a new leaf node and deletes the input? And then that's the only API that is used to operate on those sort of, obviously that only works for the leaf nodes. It doesn't work inside of the tree. But it may be that defining it in terms of an API makes extremely clear what the...
It could be, yeah. I mean,
just a suggestion.
Yeah, that might be, like, if you'd like to take a look at how to write that down, I'd be interested to kind of see that written, because I think, yeah, I've certainly thought in implementation terms of like creating a secret, C++ class that tracks its dependencies and automatically back propagates that deletion. You can do some clever things in implementation like that. I'm not totally sure that there's specification ways to do that, but it might, if you have a clever way to write down, it could be.
Actually, that's exactly what we do in the security proof. We do this one-step expansion of the 3 things together.
Great. So Riyad and Benjamin, you should talk and get a PR. Okay, I think that's the main backward-looking stuff. In terms of where we're going with the spec, I think we've been trying to kind of match spec versions to meetups, interims or IETF, and we've been doing interims roughly every, once in between every pair of IETFs. So I think we'll discuss this later in the meeting, but I think roughly late September is the target for the next interim. We'll probably try and have draft 08 ready for that based on the proposals we're talking about in this meeting, and anything else that comes up as we try and do implementation. My hope, we've had a little bit of, I think, of divergence in the implementations. We still have, 4 or 5 implementations going. So most of which I think are open source, maybe a couple of closed source ones as well. But I'm hoping that as we get a little more stability in the API or in the spec over the second half of this year, we can start to get a little bit more alignment in the implementations. Draft 09, is obviously farther out in the future, a little more uncertainty. Hopefully would, we'll get feedback on 08 at the interim and do 09 for the IETF. I'm hoping that by 09, we'll start to be making smaller and smaller changes and start to stabilize as we get to the IETF and to the end of the year. So this is kind of my view of the glide path. I feel like we have a good conceptual framework. We're doing some optimization work now to make the performance a little better. But I think as we get some security analysis results coming in, and as we get some confidence in the usable performance of this, we should be able to start stabilizing about the end of the year. So that's kind of my, rough prediction of the future.
So some of the reason why we set up MLS this way was to kind of mirror what TLS did and having terms of implementations and the like. Are you seeing that? I know the answer. I'm giving you a softball question so everyone else will know the answer. How the implementations are coming along and whether they'll be somewhat aligned with draft 09 coming towards the end of the year, so we'll be able to prove out that it works, because some people have told me it's a couple hundred lines of code and it's not that bad. So I'm hoping that it's not all that bad for other people and get multiple implementations to show that we've proved it out.
So obviously the specs, the implementations tend to lag the specs by a little while, right? So if 09 drops in, say, early November, it'll take a little while for the implementations to catch up. Maybe we can use the hackathon at IETF whatever at 106 to catch people up. I don't know if there are implementers in the room who want to comment on this. Benjamin, I think you've got a stat going. How close are you to the spec right now? Personally, my implementation is not up to the current spec, and so
So if we are talking about not very efficient implementation, typically the formal spec that runs, I'm basically as up to date as I can. I think the only thing that's slightly different is I don't have exactly the same application key schedule, because we landed it just like a few and we need to do the proof that it maintains the secrecy invariance and all that stuff before I can claim that I'm up to date with the draft. So there is we have multiple implementations, right? We have the formal spec that's completely inefficient, highly recursive mathematical specification that runs still, but it's not a performance thing. It's just an interrupt thing. And we have one that is efficient, but this one is further away. I think it's like 2 or 3 drafts away.
Okay.
And so the implementations you're working on are somehow verified. Can you comment just briefly on what sort of verification we'll get once we have that, the match between that and the spec?
Okay, so the idea is that we have 2 implementations, one which is high level using recursive data types for trees, etc. So it's very compact. That's the few hundred lines of code that Sean referred to. And we have multiple thousand lines of code that is efficient and reasons like you would reason in C. And this one is further away, I think. But for interop, I think the formal spec, which enforce the security proof, which means secrecy invariance, all these things, is quite close. So I think that's helpful in some sense.
I think that's the one that's sufficient, the one that you want to make go super fast.
So
that's up for you, what you want to do with that. But just in terms of trying to prove out the spec is really kind of what we need, and having multiple helps.
And this one you can do most of the algorithms. Actually, you can do everything, I think.
Okay.
So we can interop on P256, on Curve, on Chachapoli, ASDCM, whatever. We have all the crypto we need.
Yeah. So that may be something to discuss as a target for the interim. Maybe we can get a draft 08 out a bit in advance of the interim so that people can have some time to implement, maybe do some interop testing alongside that. That's a good idea. So that's to try and keep up a little bit better. Yeah. All right. Now, so that's current spec status. Any further comments on that? Questions about where we are right now? Okay. So next couple of topics are about things that we might like to do to make the spec better. First thing I'd like to talk about is this idea of laziness, and the lazy phrasing comes from Raphael. Most of this idea is due to Raphael. Let's put the wire logo up there to kind of share some credit. So the idea here is, I think a lot of the motivation here Raphael described this a lot in terms of bringing a new device online. So when I bring a new device and log into a new device, it has to join all of the groups I'm in. And if it's got to do a whole bunch of DH operations for each of those groups, that gets to be very heavyweight, especially if I've got a lot of groups going on. So he came at this looking at what can I do to make that new device onboarding process easier and make it, say, constant time operations to join a group or to update into a group. The observation I'll start from here is that the secrets shared by the group only need to be updated if there's messaging. So if I've got a group and I've added 15 people, I've removed another 5 people on the other side, and 30 people have updated their keys, all of those changes have no significance if there's no messaging. So the underlying approach here is to take all of the crypto math you would need to do to update the key and defer that until a message needs to be sent into the group. We're not doing that right now. Every time you do an operation, every time you add someone or remove someone or update a key, you have to do all of the DH operations to update the group secret, even if there's no messaging going on. Yeah, Ecker.
How does that work if you're encrypting handshake messages?
Good question. I admit I have not thought about that.
It seems to me
Yeah.
like part of the operation here, when I join the group, is to get to a new key that I understand. And so when the next person wants to send a message, presumably they need to encipher to that key, not the old key.
Yeah, I think maybe part of this concept would be kind of a notion of sub-epochs, right? So if these things don't only change the tree and don't change the group's secrets, it's possible you could keep encrypting the group messages under the same epoch keys.
I guess maybe that's part of the understanding, because it seems to me
Yeah,
that
yeah.
like we have a group of 3 people, the 4th person joins, and the 5th person, I just don't understand how it works, right?
Yeah.
I mean, I just started thinking of this, like I could be totally like wrong, but
No, it's an excellent comment. I don't know the answer to that.
okay.
Yeah.
The expensive resource here is the Diffie Hellmans, right? It's not the hashes. Okay.
Yeah, no, absolutely. Yeah, and so in the add case, yeah, you may be able to just hash things forward, as long as you can get the right stuff to the new joiner. Yeah. Yeah, so, right, the proposal here is to do cheap stuff up front and modify the tree, right? Modifying the tree is cheap. You're just emplacing, you're storing public keys. And then before you send a message to the group, you encrypt to the tree, you encrypt some new entropy to update the group secrets. And then you incur the cost of all the DH operations. So I think of this kind of as a rearrangement of the operations we're doing. Like, it's nice that we kind of got things, we understand that have a taxonomy here and we can just rearrange things. So if you look at the way the current operations are structured, when you add someone to the group, you emplace their public key at the leaf they're being added to. You blank out the path from that leaf to the root, and then the group hashes forward into a new group secret. When you update, likewise, you reset the leaf and you encrypt some fresh entropy to the group that refreshes the group secret. When you remove, it's kind of like a mashup of add and update. You reset the removed member's leaf to blank. You kick them out of the group and you reset their direct path to blank. You encrypt some fresh entropy to the group so that they no longer know the group secret. So really the idea here is to take the expensive stuff. So like hashing isn't that expensive, but maybe, these encrypting fresh entropy to the group involve log size DH operations. So those are the expensive things, especially if you have to do them across a whole bunch of groups. So the proposal here in kind of protocol syntax terms is to take the add, update, and remove operations and chop off the expensive parts. Right, resetting leaves and blanking paths, those are just changing bits in a data structure. They're very cheap to do. And then take the expensive stuff on the right-hand side here and make a ratchet operation that encrypts some fresh entropy to the group and advances the group state. Joe, did you have a comment?
Does this address what Ecker's talking about in the sense that if you get a new ad before you've done the expensive stuff, you need to do the expensive stuff? before you get the next tree change or.
I forgot to make the illustration here that I made a note for. Yeah, there's a corollary to this, that you need to have a rule, and Raphael will get to you in one sec. If you're going to split things out this way, you need to make sure that this ratchet operation happens before you send a message, right? So the adds and updates and removes have been reflected in the tree, but they're not reflected in the group state yet until you do a ratchet. So if you're going to send a message, you need to send a ratchet first to update the group state so it matches the tree. I think that's the major risk here, is that you need to get that timing right and have clear rules that people abide by. Yeah, Raphael.
You could just go back to the slide.
You're a bit close to the mic.
Oh. I have these earpods. No idea how I can make that.
Yeah, no, you're fine. Go ahead.
Okay. If you could go back 2 slides. Yes, so that one. So on the update line, I think if we want to make it very explicit, we would also have to say that
Raphael,
blank.
could you pause for a second? We're trying to adjust.
Yes.
You're quite loud. Someone's going to the audio mixer.
Okay.
We have these. Colin, you turn. Raphael, could you try again?
Test. Is it better?
Nope. Colin, you turned off the front. Raphael, can you generate some signal here so that we can figure out which knob is the right one?
Is it a bit better? Hello?
That's
MLS,
great.
MLS.
That's great. Go ahead. Colin, can you turn the front mic back up? Go ahead, Raphael.
All right. So on the update line, I think we never said that so explicitly, but you also blank the direct path when you send a normal update. And then you overwrite it with new values. So in that sense, the update is equivalent to the add and remove. Because right now it visually looks as if it was different.
Sorry, I think your audio came through a little garbled. Can you maybe restate that?
So in the second line with the update, there is one box missing that is blank direct path. And I think that's what you also do implicitly when you do an update, because you then overwrite that path.
Yeah, I think that's right. And I probably should have included that here. I was thinking that the encrypt fresh entropy box also carried fresh public keys, but you're right that if we're doing this in the lazy style, we need to do the blank at the update time. That's correct. Yeah, thanks.
All right.
Okay, are we back to volume here? Okay, great. Yeah, sorry, I forgot to draw a picture of this. We've got better pictures later. Let's see, yeah. So this would be a fairly major refactor to the protocol messages. We'd have to create this new ratchet operation that describes how you encrypt stuff to the group, but and obviously strip out the updating bits of the current operations. But like I said earlier, it's largely just rearranging things and moving things from one place to another. It may actually end up a bit simpler because we'll only have the tree updating logic in one place instead of spread across 3 different operations. So could be useful. So just to highlight the trade-offs here, as we set out to do, we've made the modifications to the group happen in constant time before you send a message. So if you've got a group that's not doing any messaging, they're just sitting there maintaining the group, you incur very little costs to keep the tree up to date. The trade-off is that when you finally do a ratchet, it's more expensive. So imagine you have a tree where it starts off as full, all the nodes are populated with public keys, but everyone in the group sends an update before the next message is sent. At that point, because you, as Raphael pointed out, you have to blank when you update, you now have a tree that is only populated at the leaves. So when you finally send that ratchet operation, it has a linear number of DH operations to encrypt to each of those leaves individually. So there's kind of a life cycle to the group now that, you know, when that as it sits there and is inactive, the tree kind of degrades. And it becomes less populated as updates happen that blank out parts of the tree, and then it gets reconstituted as people do messaging and send ratchet messages, and that repopulates it. So, I mean, this, right? So if people don't do these ratchet operations very, very often, they could be quite expensive because the longer you go between them, the more expensive they are to do. That's kind of the trade-off. The one thing I think is promising, and I'll talk about it a little bit more in the next topic here, is that because the add and remove, update and remove don't have any secret information, they're just talking about public keys to put in the tree. You know, an add message just says, put this public key in a leaf node. A remove says, blank out this path. Anyone can generate them. And so we've talked off and on for a long time about enabling servers to do adds and removes. And so reframing add and remove in this way could make it easier to think about those server-initiated operations. I think server-initiated remove, sorry, there's some noise. Server-initiated remove is very straightforward in this. You mark a server as the server's public key is authorized to sign, and that server can then send you a remove message that says blank out this path, and it's blanked and it's realized when the next member of the group ratchets the group forward. So it's a much cleaner way of thinking about these server-initiated operations. I think the major risk here, besides the cost of doing the ratchets if we adopt this, the major risk I think is the risk of this timing of the ratchet operations. That you really need to have a ratchet operation sent before any messaging is done, before anyone uses the group secrets, to take all the changes that have been bunched up and apply those and update the group secrets so that they reflect the current state of the group. So, I mean, this is kind of the trade-off space. I mean, what do people think? Does this seem like useful? These seem like worthwhile trade-offs? Seem like we could stay away from this? I guess I should add to this the point Ecker made about we need to figure out how this interacts with encrypted handshake messages. But my general impression is this seems worthwhile. But if people are concerned about some of the costs here, be open to discuss.
Joe Hall, so if you have a group that doesn't talk a lot, say an emergency response team or a DFI.
Can you speak a little closer to the mic, Joe?
So, hello. So if you have a team that does not message a lot, but needs to get up to speed really quick, if it's a big team, that first message you're gonna be sitting there staring at something for a little bit. And so it might be either this isn't gonna be appropriate for those uses, or we might want those folks to be able to, I don't want to use the word heartbeat, but whatever I just did, have something that passes a message through that sort of pushes that stuff through in a more periodic basis or something, right?
Yeah, it's a good point. Like, I will point out that the balance here is between how often you ratchet and how often you update. So if you ratchet seldom but update a lot, then the updates will blank out the tree and your ratchets will become expensive. If you ratchet every time you update, then your tree is not degrading. So to some degree, we're like punting a choice to the application there. We're offering an additional complexity, an additional knob to the application there to control the state of the tree. In your kind of first responder case, it's an interesting one. So like if you imagine that everyone's been quiescent for a while, but they've been sending updates because for PCS, there is kind of a warm-up phase, as we have with a new group. So you basically end up with only leaves populated. And then when you start talking, someone will send an update that'll populate a path so that certain things will be more log-like. And gradually the tree will kind of warm up as it gets more populated and things will converge from linear to log. I think a couple of meetings ago, Raphael and I both did some simulations of this under, certain assumptions about how often things happen in the group. And you can kind of see a convergence pattern and it goes up and down as things happen in the life of the group. Raphael?
Yeah, I just actually wanted to comment on exactly the same thing. So I think you already said what was important. Just one more thing for context. When I first thought about it, I wanted to defer the hard computational work and payload costs from the device that is being added to an account or a group. But nothing precludes this device from paying the cost later at this point, or another device from the same account, for example, that would do that if there is enough time and if it's just in terms of strategy, if it's a good time to take that decision. So this concept would essentially bring more flexibility, but with the right choices, you could probably avoid the situation where you completely degrade to linear.
Go ahead, DKG.
This is Daniel Kahn Gilmore. I guess I have one concern and one question. The question is just if you could elaborate on the asterisk there, because if you mentioned that, I didn't catch it. And my concern is that it seems like you're saying taking this approach or requiring this approach is what permits this can be sent by any authorized party thing, that it permits server add. And then if we don't do this, there's no way for servers to do dynamic, to do server initiated adds or removes. So is that what you're saying? Because I'm sorry, I'm struggling to follow the changes here.
Yeah, so these are conjoined. So the asterisk on the add is that a server, a non-member of the group can create an add message and to tell the group to add someone to the tree. But even with this change, the server can't generate, this is actually the next topic, the server can't generate the welcome message that provisions the new joiner with the secrets for the group because the server doesn't have access to the secrets of the group. So this doesn't solve the server initiated add case. I've got a different proposal for how to address that, which has some different trade-offs and may or may not be worth it. But right now, this need to be in the group, I think the need to encrypt fresh entropy to the group prevents server initiated stuff at the moment. So you couldn't say have a server generate a ratchet message in this new framework.
Okay, so I should be clear. I'm not convinced that the server initiated stuff is a boon to the protocol because it smells like wiretap capability. So if not doing this means that we can prevent the server initiated stuff, I think that might be advantageous.
Okay. Well, actually, Edgar, one quick response to DKG. I think just to put some bounds on this, I think to the degree that server initiated stuff is possible here, I think there's pretty good agreement across the group that it will be explicitly authorized. You'll have clear authorization for who's authentication of the sender of these, the originator of these things, and they'll have the same authentication properties as for the added user as if they had been added by someone who's already in the group. So I agree that depending on all sorts of UI considerations, what have you, like there's risk to things going unnoticed, but at least at the cryptographic layer, there's not a difference between the device, the member authentication in the server initiated case and the member initiated case. But happy to discuss this more. Yeah, Ecker.
My understanding was that the rationale for the server initiated stuff was to a great extent to allow new devices to be added without cooperation from old devices owned by the same user, right?
Can you say that again?
Yes, my understanding
maybe a little closer to the mic.
Was the rationale for having server initiated add was to allow me to add a new device to the system without having access to an old device or some other person to let me in, right?
That is one of the cases.
I'm not saying there aren't other cases, but my understanding was going back to the original requirements here were about as I recall, had the property that say my device is completely destroyed and I want to rejoin, what do I do, right? And my understanding was the server initiated was the answer to that question. Now, it's absolutely true as DKG points out that like that's like a dual use technology, but like it's important to understand what we're trying to. So maybe we maybe we can say like I don't want that functionality, right? But I think as far as I understand, that's if you don't have server initiated, that's where you end up. Is basically then if I lose my device, I'm screwed.
Yeah. Well, you're screwed until you
Yeah,
can
exactly,
get
yeah.
someone else in the group to add you.
Yeah, right, yeah.
Yeah.
And then I have to somehow persuade them that, like, and then I have to somehow persuade them that, somehow persuade them that I'm the same person, right?
Yeah. Yeah, I mean, the other implementation path that have been discussed for server-initiated operations would be to allow the server to send a request to the group that a certain operation be done.
I mean,
so that someone in the group could then perform the action.
I mean, I think just trying to think about the sort of general equilibrium effects of this, my suspicion is, in an environment that does not have server-initiated add, what will happen is that anybody who operates a big service will basically implement server-side key escrow for the signing keys.
Or we'll initiate, we'll basically have an API by which the server can request that any device that's online do the add on its behalf.
I don't see how that's actually materially different from server-initiated add, though. Do you?
No.
Okay.
No, it's different in protocol terms.
Yeah. I mean,
but it's not different in functional terms. My
Sure.
point is like you can do this around the side even if the protocol doesn't support it.
Sure. I guess. Right. I mean, that seems like I mean, that's it. That design seems like distinct. I mean, I guess all the design seems very clumsy. I'm just trying to think of things as an application implementer, like how a sensible way to implement this would be. And it seems like, yeah, it seems like there's going to be a bunch of like complexity. I mean, I guess the assertion I'm making is like based on having talked to people who built big scale systems like this. They all seem to implement some kind of recovery mechanism when your device blows up. So they're going to do it. And so the right question to ask is, how would we prefer they do it?
Yeah. So you said something about complexity, which between the like incorporate it in the protocol option and the build an API that orchestrates the protocol option, which of those seems worse to you from a complexity point of view?
I mean, I think orchestrate the protocol option. I mean, like, if we put aside the concern about unauthorized or initiated ad, which you can't put aside, but I just want to put aside for like 10 seconds, then the ask somebody to do it seems like obviously materially worse. I think the question I'm interested in is there any material security difference between server initiated ad and server like solicited ad or whatever you want to call it, right? And I don't know, I haven't had time to reason about it, so I don't think I can answer that question.
I think there are noticeable differences. I don't know if they're material differences, but for instance, in the case where it's in the protocol, you have the signatures by the server in the transcript and clear and agreed on by the group, and so seems like there is extra accountability in that approach that you don't get in the orchestration approach. So just keeping track of the agenda here. This is a bit we're a bit far afield of this topic, but the next topic is how you do server initiated ads.
Sounds
so
great.
This is great to have this. It's fine to have this conversation now. So, actually, yeah. Let's do that. Let me make the proposal. Let me make the proposal for how I think we can do it, and then we can discuss whether we want to. All right. So, not hearing huge concerns about this, except for the server initiated part. It sounds like we are. It's helpful, Joe, your observation that we are kind of opening up a little bit more complexity for apps to have to manage. As we write PRs here, we'll have to think about how to talk about that. Yeah, Riyadh.
Riyadh Wabi, quick question. Do you have a sense for what the range, so it seems like the point here is different groups with different use cases will have sort of a different optimality point. Do you have a sense for what the range of those optimality points is? Is it sort of gigantic or is it rather narrow? I don't know. That's a very open-ended question. But the point is, like, if you could imagine that, like, if two different groups have some setting that's off by orders of magnitude, then intuitively, it feels like having this tweak must have been important. Why else would this setting be off by orders of magnitude? But if the optimality point is relatively flat, then maybe it's okay to pick one number and say, yeah, it's not perfect for everyone, but good enough. And then at least you get rid of the possibility of misconfiguring it. So it might be useful in terms of making a decision just to understand how big that range is and how steep the trade-off curve is.
Yeah. Yeah, I think there's enough variability in the considerations here. As you heard, there's a couple of different motivations for how you arrange this. So it might not be quite a linear scale,
Sure.
but yeah, I'm happy to have some considerations around. I think, yeah, inevitably we'll have to have some guidance text around. We'll have a hard boundary that say you must send this ratchet message before you message if there's been any changes, but you can send it at other times as well. And we can phrase some explanatory text or guidance text around that. Sure. Okay, so I think I'm getting the feeling here that this is okay with folks. I think I'm interested in this. Raphael is as well. So I think we'll go ahead and start working up some PRs. Now, server initiated ad. Since this is clearly an important thing that everybody wants. So if we're going to go toward this lazy framing, where we have the ad just in placing a key and blanking its path, and then someone else's ratchet will merge it into the group. The server can synthesize an ad, like I said, but not the welcome. Welcome contains the init secret for the group that initiates the new user into the group's secrets, and the server doesn't have that secret. So earlier in the very, very early drafts, I think maybe not even working group drafts, just the individual drafts, we had this idea of a group ad where actually it's user ad. I've gotten this backwards. So in the initial version, we had user initiated ad and group initiated ads. You would do a group initiated ad when someone added you to the group. You would do user initiated ad when you wanted to join the group proactively. And that basic difference between these is that in the group initiated case, you would use a KDF, as we do in the current document, to go from the init secret to the next epoch secret. And in the user-initiated ad case, you do asymmetric cryptography. So you publish a public key whose private key is known to the group, and you take that and you combine it with the new joiner's init key, and the output of that DH operation is the new epoch secret. In pictorial form, right now we're doing the left-hand side of this. So you take the init secret, possibly with some update secret, and you HKDF to get the new epoch secret, which is the starting point for the key schedule for that epoch, as Britta's slides showed. The change here would be to do this right-hand side. So in addition to maintaining this init secret, which is a symmetric secret, you could generate off of that a key pair and publish this group init key, which would be a public key, again, whose private key is known to the members of the group. So that if you wanted to have a user add, you could take an init key, again, an asymmetric key pair, and do a DH operation between those two key pairs and use the output of that as the new epoch secret. So now you would have a user initiated into the group secrets without having to explicitly hand the secret to them in a welcome message. And so that you open up the set of people who can generate that welcome message because you're only distributing public information or non-secret information, at least, in that welcome message. Syntactically, this slot used to be the init secret. You just replace it with the public key that was mentioned on the previous slide. Other than that, this would merit some thought. Again, to Ecker's earlier point, when you're doing all of this in the case where you're encrypting handshake messages is a little squirrely. This would probably have to be we'd have to figure out how this interacts with handshake message encryption. But at least in terms of managing the key schedule and managing the group secrets, you no longer have the init secret here. We could probably also have some discussion about whether we regard the contents of the tree and the transcript hash as sensitive. Open to debate on that. So on the one hand, one of the things that was unpleasant about the earlier versions of this is that we had two flavors of ad. We had a user-initiated ad and a group-initiated ad. I think if we were going to do this, we would just move all ad operations over to this asymmetric framing, and so we'd have one ad path that was used for both of those cases. You know, it is useful in that it realizes the server-initiated add feature if we want to have that feature. And I think there's kind of some intuitive appeal in that you're no longer directly handing out secrets. You're doing, it feels uncomfortable to kind of extract that init secret from whatever container you had it in and send it out over the wire. And so here you avoid doing that, and you still end up unable to initiate someone into the group. That makes me feel better about, you know, the ability to say, do this in a FIPS validated context where you might have requirements around the storage of the secrets to store them in non-recoverable storage, right? So you could, this might open up some additional deployability of this protocol by not having to pass around secrets. On the other hand, there's more complication to the authorization story if you're going to allow the server to initiate things. So right now, the signing structure we have is it just has a pointer to a leaf in the group, and you just have to look up the leaf there. This would presume some additional, you know, externally imposed, externally authorized keys that could generate these messages into the group. And you have to posit something about how you manage those, how you refer to them when you're generating messages. I think it's a solvable problem, but it is more complexity. The possibly cryptographically interesting bit of this is right now, all of our asymmetric cryptography is HPKE. It's encrypting to a public key. And that allows us to use chem constructions at that level of generality. So that's nice because you can realize a chem with DH, but you can also realize it with pure chems. And there's a lot of post-quantum, a lot more post-quantum work on chem-like things than on DH-like things. So there's some kind of post-quantum niceness to operating in this chem framework and not depending on DH. If we were going to go down this path, it would lock us into having a DH-like primitive. Now, there are post-quantum options there, but my impression is that, you know, other folks who are more familiar with literature, my impression is that there are fewer choices there, and at this stage, at least, less validated than the chem options. So if we were going to go this path, we would be kind of locking into a DH dependency. Which you know, might limit our post-quantum options down the road. So that's, I think, the last slide on this topic. Discussion. So, Ecker left, so I don't know. DKG, do you have more thoughts on server-initiated stuff?
This is Daniel Kahn-Gilmore. So this discussion here hasn't changed my perspective on the server-initiated concerns. And just to rewind to what you were saying about the different constructions, you had said that you thought that the server add, which was part of the official transcript, provides more accountability. I don't think it provides more accountability than a server invite. If we formalize a way for a server to do an invite and then expect someone from the group to do an authorization or something, I think the same level of accountability is present in that case too. Of course, if there's an out-of-band server invite, there's nothing we can do in this protocol to prevent such a thing from happening anyway.
Yep.
So, yeah, I'm still uncomfortable about the whole arrangement, because I mean, particularly if we're talking about the use case that Eric was describing, which is I lost my device, I'd like a new one. It's very hard to see what recourse other users have other than a regular message that says, "Hey, Richard Barnes got a new device," which doesn't mean there's a new listener involved on this channel.
Yeah.
And it's very difficult to tell how you would explain that to the user that an otherwise unauthorized listener has been added. So I'm very wary of us building mechanism that supports that kind of wiretap.
Yeah. Yeah. So, yeah.
Jan Metzger, BSI. I'm not saying that this is the one only true divinely inspired way of doing a server-initiated add, but I see a real use case for having a server-initiated add capability inside the protocol, because we have many use cases where a group wouldn't probably be entirely regularly used and self-governed and so on. And so if I can use the server to govern basically who's inside the group, who's outside the group, and so on, then people will use it. And because there is a use case, I believe vendors will find a way to misuse the protocol or to circumvent the protocol in order to give me this capability. I mean, I can always add the server as a member of the group and basically just use my MLS clients or instruct my MLS clients when I'm a vendor in a way not to display the server. And then I'm in a use case that's pretty terrible because now I'm misusing the protocol in order to get this use case I really want. So I'd much rather have a nice protocol integrated, accepted by all kind of fashion to do these pretty basic group interactions than basically have a use case open and inviting vendors to do whatever they want instead of a nice protocol way.
So yeah, let me just note, kind of to DKG's point earlier about the invite, the server. What was the phrase you used? Server solicited. This, I think the server solicitation. If you include the solicitation in the transcript and it's clear it's bound into the session, I think there's similar properties in terms of. I agree. There's similar properties in terms of accountability to having the server actually generate the ad. It seems like the main difference between those two approaches, and I'm totally open to having discussion about which of those two approaches makes sense here. I think we probably want to do one of them for the reasons John mentioned. It seems like one thing that the server solicited ad doesn't address is a case where you have a group where the existing members are all offline, and you want to enable someone to join and immediately transmit into the group, right? So if you're reliant on someone else, an existing member of the group doing the ad, then one of them has to be online before the new member can participate in the group. Okay, so that's just observation of it. Okay. Just for the record, that was DKG saying that property is a feature. Britta.
Britta Hale. I really see the use case here of having the server initiated, but I will say that the omitting post-quantum or limiting it down to a selection of just a few or even a subset of the available protocols out there is rather serious. And I would very much like that didn't happen. I think if we want to have a server initiated, then there could actually be a middle ground here that isn't being considered, where it doesn't lock us into DH, where you actually might say, okay, we'll have a server initiated under serve DH and look at, it will probably add some sort of complication to the construction, it'll add more overhead, but to find a way where the main group is still working with chems and the initiation isn't. There could be something there, but it will mean a lot more overhead.
Okay.
Yeah, I mean, it seems there's some variant of this where as each epoch produces effectively a public key that you can cipher to, and then you can you split the difference between send and receive, where you can send without anybody being online, but you can only receive when somebody is online, right? That's a possible way to split to get you out of this DH kind of structure.
Yep.
I think I want to go back to first principles, which is like, when we've talked to the people who've built a number of these systems, it's clear they're going to build something that looks like server initiated at the application level. And the question, and so I think we have effectively three options. One is build no constructs whatsoever that permit it. The second is build constructs which which sort of tacitly permit it, but don't really support it, which I think is what you probably call server solicited ad. Basically, what's the supporting material? I think there's two versions of this. One of which is the ad. We just add an additional authenticated data block to every ad invite, and then you can just shove it in there if you wanted to for logging purposes. And there's some other version where you're actually expecting the we're actually expecting the consumer of the ad to go and verify that the solicitation is valid, right? So I mean, like there's one version where it's archival, another version where actually what you're supposed to do is a receiver of the ad is say, okay, DKG added Ecker's new device on the basis the server asked him to, and now I go and I verify both that DKG did the addition and that the server actually asked him to, as opposed to it just being sitting there and for posterity,
Yeah,
right?
well, for example, if the solicitation were signed, then you have similar thing.
Right, but I mean, you can imagine not verifying that. Imagine just saying like, well, he just says this is true, and then later it turns out like two years later it turns out you're just lying, but like nobody checks at the time, right? Nobody enforces it. And then the third option is to actually build an added capability. And I don't like, it's hard for me to know what the best one of these things is. I'm certainly sympathetic to the idea that like feels bad to like be designing a system which we know like will be is like a misuse vector. But I think let's not fool ourselves that in the mass majority of systems the other users do anything other than the other user clients would anything other than robotically like do whatever the server asks them to do, right? And similarly, it's possible, and similarly, it's possible in a system which didn't want server initiated ad simply ignore the server's message to that effect, right? And I think that's so. Like, let me offer sort of a counter argument to the implicit thing that we're building something which we expect to be misused, which is that if you want to build a system where you don't want server initiated ad, right? Like, are you better off? Are you better off in a world where like you want the other clients to omit the ability to respond to solicitation, or are you better off in the world where you yourself ignore all the you yourself ignore the ads? And I don't know. I think I can imagine an argument that goes both ways. I mean, so here's my hypothetical bad argument, right? Say you have like all the messaging systems we have now basically have like captive client server systems, right? Where the client and the server are written by the same people, right? But imagine a world where you had an open system, right? And so now you have a system of n people, and everybody brings their own client, and the clients are varying qualities, right? And so now when I join, I accidentally misconfigure my client, so it is not designed to, it doesn't refuse to respond to server solicitations, right? So now, if it's not built in the protocol that those solicitations are manifest, then the whole system is screwed, right? Whereas by contrast, the system where people can individually configure their clients to ignore the server solicitation, then you get a break instead of getting you get a partition instead of getting the system being screwed. So I think that's really a very strong argument against not having any feature in here for this, because then like if the response to solicitation is just to blindly echo it and not to have any enforcement that the server actually initiated it, then there's very high probability that if you have a client which is capable of participating in either non-server initiated or server initiated networks, that you'll get crosswired. Whereas if you force the thing to be manifest, then that can't happen, because then at least then what will happen will be that when I program my system not to accept server solicited ads, then we'll get a partition again. So I think like you really wanted the property that like one misconfigured client can't screw everybody over. So I don't know if that helps us distinguish. Is that all persuasive? You're like making a face, and so maybe I'm just like totally confused.
I can't imagine a system like this, which actually is an open world system, where one misconfigured client can't cause a partition, regardless of whether we do server initiated ads.
Oh, sorry. My concern is in this case, I wanted to cause a partition. So I guess let me tell you the story that I'm trying to tell again, which is we have clients which are configurable, which are configurable to like which can operate in either a server initiated ad server, like we can operate either in environments where servers are supposed to be adding or they're not, right? And so because we have network A, which has server initiated ad, and or server solicited ad, network B, which does not, right? And so if I take my client, so if I have a client which will actually respond to server solicitations, right? And I join B where not supposed to happen, but that client for some reason is incorrect, and will respond to server solicitations. That client basically represents a threat to everybody else on node B, even though it's a perfectly valid on network A, right? And so if we force the response solicitations to come with a whole attestation chain, then
Ones are cut, by the way.
then if anyone else on node B properly checks the chain, then that misbehaving client gets detected, as opposed to just like blindly adding you.
Yeah. All right.
I'm not loving any of this. It all feels pretty bad, right?
Yeah. So yeah, I think we need to have Joe. And
So
then
very, very quickly, I just want to make sure we support the use case where a group really wants to have humans in the loop for adding. And so I hope it's not all silent server initiated stuff, and that we can also have groups that as a policy sort of require a human to hit a button or something.
Yeah. I don't think any of this was to say that we wouldn't have self-managing groups, but to also allow external. All right. Well, okay. Thanks for the feedback. I will continue to think if we can address some of these, but it's useful having this framing of how do we guide things properly. So I'll take another shot at this. Thanks.
3 decks in 35 minutes, man. Terrible. Okay. So we have less controversial things to discuss now. Typically, there is one thing that has been recurring over the last few meetings is HPK. So right now, when we do hybrid public key encryption within a tree, or actually to a specific new member that's going to be added to a group when you want to send him some public information encrypted under his public key, you are using HPK. So there is a draft from Richard that is now an IETF CFRG working group draft in progress. And the current state of the things is that basically when we encrypt to a subgroup or to a leaf directly, we use HPKI with basically no PSK. So in HPK now we have a mode that supports PSK. We don't mix in the identity of the sender, and we basically provide no information. And at the interim, for those that weren't there, we discussed a lot with Karthik and Kaz and many others, the fact that in many of the encryptions, in the AAD, in the HPKE encryptions, we don't have any context right now. And that's basically something that's problematic regarding cross-group attacks, etc. So the idea is that we want to add more context, more binding to the current subtrees on the left and the right through the HPKE encryption, and basically we want to do the same for IAD as well, because there is a spot to put more information there. So one question is whether we should put a PSK there. We definitely want to at least mix in the identity of the sender. And we have the spot for the information. In the security proof we have, basically, in the symbolic model at least, we don't do any additional diffie-Hellman with the identity with the long-term static key of the left subtree. But what we do is that we mix the entire public tree actually of the person that actually sends, so that there is agreement at all times between the person that encrypts and the person that receives the encryption over the public tree. It's only those two, right? It's not the members of the tree that agree, but at least for the person that receives, he knows he has the same view as the participant that encrypted. So basically, the global ID is like quite very uncontroversial. The idea is to put more in there. The current state is that we bound anyway. The ciphertexts are bounded to the subtrees because you use the public keys, ephemeral and static key of the work group and for the HPK. Now, is there any specific reason to add a PSK in there? Not sure. That's not something that we are doing. It seems that mixing the information in the context is enough to ensure that there is agreement. Maybe there are some other reasons to do that. let's see. And we definitely, apparently we don't need to do an extra DH operation either. So it would be good to have more analysis on this. The preliminary is that we don't need it. But some analysis might say that we actually need to do it.
So Richard Burns, just I'll be brief because we need to move on here. But I think the short answer here is I think we should put in to the symmetric inputs, either the PSK or the info, whatever you like. I would very strongly prefer we do not do the additional the PKI, the initiator.
Yeah, me neither.
Because it's crypto expensive and has these rigidity we lock into the DH authchem stuff. So yeah, I would strongly prefer to avoid doing the public key stuff, but please, academics, Britta, Benjamin, tell us what we put there.
So that's it. So that's an intent. We'll try to add more context inside the key derivation, etc. If you have any concerns, I think it's an interesting point, especially on the PSK point. If you see, if you have like use cases that might need the PSK thing, it would be interesting to know. Another topic that we discussed recently, we talked about what we call non-destructive add, which is basically the fact that when we were doing adds currently, we were blanking. So to recall, what we do is that we insert, when we add F to a tree, we insert F in the tree and then we blank. So the other solution to that, so because we blank, we lose efficiency, right? Because now we need to encrypt to this guy, and this guy, instead of only the root secret, the root node. So a different thing would be to basically don't blank at all and encrypt to two subtrees, because you actually maintain the secrecy invariant in the sense that you already have nodes that are filled with keys for the subtree. Only F doesn't know those keys because they haven't been sent to him. So the idea is that we, instead of doing only one encryption to the root, instead of doing the destructive case where you encrypt to those three nodes, in this case, what you do is just have a full subtree, and instead of instead of sending to the three nodes, you encrypt twice. One for the root, the existing root, and one for F. So you came 2 times. So if you take a more subtle, more complex example, it reflects a bit more why it's more efficient. So imagine you have a full tree, you remove C, E, F, and L. So now you're in a state where you have 6 heads, those black heads, and you need to encrypt to all of them, right? Imagine someone like A adds and recovers basically his full path up to the roots. So in that case, you just have to encrypt to that guy, right? If now you do the destructive add and add C, you would kill all those previous nodes that you filled. So basically, you kill the efficiency that you just restored by having an update. So it's quite bad in some sense, because you completely destroy the efficiency of the group. While if you do the non-destructive add, basically you are just adding, you're keeping the previous nodes and you are adding one. So basically you have 2 heads, the existing one, which is on the left, basically, and the new one, which is C. So you do 2 cams instead of doing 7, sorry. And it maintains the secrecy invariant. The cost is simply that now you add a bit more complexity. I'll get back to that in the end, but it doesn't seem too bad. The protocol impact is just that you keep basically a list of for each intermediate node. You keep the index of the node that hasn't been merged yet in. So you have to do a bit more record keeping in some sense, because you have to keep track that there are 2 keys for each intermediate nodes, and that you must encrypt to those 2. But you have the benefit of having a way more efficient add, at least one more efficient group operation that follows the add. So it's actually quite good. There is something that we've been discussing a while back, is that roughly the stats that we have, maybe you can confirm this, Richard, is that the numbers of adds and removes in groups are actually very similar. In terms of the frequency of add and removes are actually very similar. It's not like there is a large difference between updates and add remove, but the number of add and removes in a group is roughly the same along the life of the group. It depends, because at the very beginning of obviously you have like more adds, but as the group keeps going, it stabilizes and you have lots of add and removes, but in a similar rate, let's say. So that's something we have to consider. It gives a bit more complexity in the algorithm for intermediate nodes, but it recovers a lot of efficiency. And I think more data would be welcome as well.
So Richard Barnes, I think we should just do this. I think the complexity is manageable. There's a little bit of weirdness on remove, but I think it's not a whole lot of code to keep all this information around and keep it live. So, and I think the performance benefits merit the extra record keeping.
This is Daniel Kahn-Gilmore. Sorry, I didn't fully understand the way the proposal is working, and I like that you've given us an example of what happens when you do one ad, but what I didn't see is what happens when you do two ads. Do we now have three? Do we have a tripartite root node?
Yes.
If so nobody have a 4-part root node and a 5-part root node?
You have a list.
So you have a key in that root node whose private key is known to the pre-add population under there. And then you have a list of leaf keys that have been populated since the last update to that root node. And so when you encrypt to that subgroup, you encrypt to the thing that was known to the pre-add members and the leaf keys that were added since.
So now what we're saying is that each message needs to be encrypted to multiple different targets, right? So we're making add more efficient while making send less efficient? Is that a good trade-off?
That was already the case.
Yeah,
right?
that was already, you already had to encrypt, like for, if you do, I don't know, if you want to send a message to the entire group here, you already have to encrypt to those guys and this guy and all the rest. So in some sense, you already have a list of keys you have to encrypt to. It's just that you try to maintain a list of people that have not been yet merged in the subtree, so that you only have to send to them instead of you can use the previous root of the subtree. That's one encryption, and then the list of people that haven't been merged yet. But that's no worse than the previous one, right?
I don't know. I haven't looked at what the overall numbers are and what the balance is for in terms of how many keys you're managing over time and how expensive the adds and removes are. I'm sorry, I didn't understand just from this presentation, but I don't understand how we judge that without seeing some numbers about what the actual amount of trade-off is in terms of storage and in terms of how complicated it is.
Matthew Miller. So, I mean, for me, I'm looking at this. This actually looks great, not so much from the frequency side, but from the size of the tree. Like, if you've got a very, very large tree, this could actually be quite efficient for ads. I mean, when you've got a really, really large tree, you're usually only getting a few ads. At least that's what I've seen from my experiences. So this would greatly simplify things, I think.
Can you comment on how large those groups are? Tens of thousands?
From what I've seen in the past with my experiences, it's been in the thousands, but on a system that ads are expensive.
So one thing to remember though is that we are constantly updating, right? So this example is nice because it reflects adding someone when the tree is partially filled. But if you have a uniform distribution of people in the tree that basically updates all the time, the tree will mostly be full anyway. And in that case, that scenario is not super interesting. So generally, I think it's way more efficient to do this. Another alternative to recover efficiency for ads would be to distribute, to relocate people in the tree so that basically you have a uniform distribution of people that actually update. And when they update, of course, they fill the entire their entire path. So yeah, it's here. Yeah, okay. A updates, it fits the path. So yeah.
So I would propose we go ahead and do a PR on this, and then we can do some simulation to validate that it's.
Yeah, I think simulation and data would be interesting.
So I think it's a very interesting idea. I'm a bit afraid of the complexity it introduces. And just to be clear, it's orthogonal, of course, to having lazy handshake messages and having a lazy add where you destroy everything and you heal only through updating or ratcheting later.
That's one of the original motivation, right? So yeah, it's worth thinking about it. I think it doesn't. I'm not afraid about the complexity because I'm doing formal methods and I can prove that I do what the thing is supposed to do. But I can understand why people would be scared about having this additional complexity there. So that's something to discuss, I guess. One more thing that we discussed at the interim, tree signing. So the idea is that when you add someone to the group, you're going to send him the public state of the tree, and the sender could actually lie, right? Because you don't have the entire history of the group, and you should not have the entire history of the group, because it would leak privacy of people that would have privacy issues, in the sense that people that were in the group before, you don't necessarily want to know that they were in the group before. What you want is the current state of the group when you added, and because that's all that you should have. Maybe you want some additional bindings with the people that are actually in the group, and actually you know, because you receive a full tree, that there are those exact public keys in the group. You know the entire state of the public tree as received by the sender, but the sender could be adversarial. So currently what we have is that we have in a subtree like this, in a triplet, you have like left subtree, right subtree, the current tree, in which you have a value, which is the secret, sorry, and hash, which is basically combining the hash of the subtrees so that you have agreement in the entire tree. I mean, you know what's under the left subtree and the right subtree. And if you have the entire public state, you can recompute the hashes and be sure that the view is consistent with the hash that's actually in the root node. But of course, if someone lies, they can tamper with the intermediate nodes and send you a tree that's actually consistent, right? You have a public tree that's consistent because if you take the hashes of the subtrees, you mix them in, you have a root hash that's correct. But actually, all those intermediate hashes could have been forged by the adversary. So what you want is a way to actually characterize who did what in the tree along the history of the tree. And especially if you have someone that sends you a public tree, you can sign all the intermediate nodes when you do an operation. So typically, if you do an update, if you change something, if F does an update, he signs the new subtree here and the new subtree here. The benefit of having that, if that is B is an adversary in the tree and wants to add someone, wants to add you, when you receive the public tree, B is able to forge on his path because he knows the secrets, but he can't forge the signatures on other subtrees. So if you're able to verify that the signatures on the other subtrees are valid signatures, except if the people that emitted the signatures obviously is adversarial as well, you know that at least with this person you have the same view of the tree. So it's in some sense, it's just like giving you some more guarantees, and like basically you can incrementally build the fact that, oh yeah, by the way, E knows that so F doesn't update. He signs this updated node and signs the root. E comes after, he will take the same thing with the signature, signs that, and go over. So meaning that if if B actually sends you garbage, you can check that the signature that has been emitted by E is the node is actually the correct one for E. Incrementally, you can build that, meaning that if F successfully sends you an update after, you inherit the fact that both E and F actually agree with the sender of the initial add that this was the correct node in the tree. So there is no perfect view of the entire consistency of the tree, but you can still get more and more information on the fact that the sender of the original tree that where you were added is conform to the vision of the other people in the tree. It's not like a unilateral blessing that it's a unilateral blessing that the current state that you have is this one, but until people update, you don't get any guarantee. Like only the only guarantee you get is when someone actually successfully updates the tree, because you know that in that case they have the same view as you as well.
So if I'm reading this correctly, the nodes with question marks on them are the ones that are actually untrustworthy?
So I didn't hear you, Iker.
If I'm reading this correctly, the nodes with question marks on them are the ones that are wrong?
Still didn't hear you.
If I'm reading this correctly, the nodes with question marks on them are the ones that are wrong. They're lies. Yes,
Yeah.
they can be wrong.
Those can be adversarial.
I'm assuming the B's. Right. So I don't feel like a lot warmer about having a situation where like the root is wrong, but the leaves are right. In terms of security objectives, I'd really be much more interested in detecting lying than I am about containing it.
Yeah.
Namely, I'd be much more interested, the thing I'm interested in is once we discover there's a partition, being able to prove who made the partition. That's the thing I care about.
Mm-hmm.
I prefer to make partitioning impossible, but since this doesn't make partitioning impossible, I'm not sure how good it is.
Yeah, fair enough. I think one thing you could get out of this sort of structure is you could force a partition if there's inconsistency by encrypting some new entropy to the non-question mark nodes, right?
Right. I guess what I'd like to be able to do, I mean, like, let's just talk about like the outcome we want for getting technology for a second, right? The best case scenario, it would not be possible to induce a partition. Maybe we don't have that. In the second base case scenario, it would be possible. The situation I want is that when I detect there's a partition, I'm able to determine who created the partition, report them, and have them thrown out of the group. So that seems like what I'm actually looking for. And I need so in that case, I need to be able to, like, what do I need? I need an outcome be a proof that is at least visible to other group members, preferably visible to the group maintainer, that they're cheating.
Visible to which group members? The group members that you don't know who they are
Right.
because you've been lied to
Exactly.
about their identities?
Yeah, because in some sense you could never, the new added participant could never receive any messages from anybody else, right? And in that case, you're screwed.
Right, because this is the ad case, right? So yeah, but then then I need to prove to the group maintainer, to the server. So like, I think that's, I mean, I guess, like, I just don't understand, like a situation where I have like this just seems like a situation where it's going to be sort of like really hard as a system operator, like dealing with a problem, like half the people can read the message and half can't, is going to be like incredibly hard to manage.
Yeah.
And so what I want to do is close that situation, remove the situation as fast as I can.
So you're saying like what might be more effective, for example, is a mechanism where you could take some description of the state of the group that I got as a new joiner.
Yes.
And bounce that against some other independent source of truth to say, does this look plausible
I mean,
for this group?
so I mean, as I understand the way the system behaves, I mean, it's like, so I mean, the way the system behaves is like I'm sending messages out and like no one can decrypt them, right?
Right. Well, yeah. Except for the outer.
Yeah, I don't care about him, right, particularly, right?
You think you're sending to
Yeah,
15
right.
people and you're only sending to that guy.
Right.
Or you're sending to.
And so what I'd like to be able to detect that state. detect that state and then correct it by basically getting a new ad, right?
So, well, so what I can foresee is that when you had added to a group, we could mandate that, I don't know, people uniformly throws an update to you, because in some sense, when you receive an update, it means that you have the same public tree as the person that sends you. So as soon as you have like a certain amount of confirmation, especially if B added C and D updates, he knows that D has the same view as he does, right, of the entire tree.
Sure. Well, I'm not asking you to solve this problem now. I'm just saying, like, I think that what I want, that's what I want.
Yeah, I think well, go ahead, UKG.
This is DKG. So I'm not exactly sure what these dotted line signatures concretely describe, what is signed, for example. But whenever I see signatures thrown in as an answer to solve this problem, I worry about transplanted signatures. That is, like, imagine that you've got two group conversations going on, and I want to graph this one subtree in over here.
So, like the proposal from Carfix, so this is Carfix proposal, is that in the formal model we keep track of the actor of each action within the tree. So when A updates for each node, we mark that A updated the tree, and here we have a public hash. Which is, we have the public hash of the subtree that gives you that here is the new state of the subtree, here is the actor that actually made the change, and you can sign the entire thing, which gives you that I did a modification, here is the state of the subtree that I modified, and now you know that it is this subtree. And in some sense, if that's only what it gives you, right? Because there is no consistency of secrets at all in that story. Because you cannot enforce the fact that you have the same secrets. Like you don't have knowledge of the other secrets, so you can never say anything about the private part of the tree. But the public one, you can always say, oh yeah, here is the current state. That's how I left it. And now if an attacker gives you the current state, which is not the same as mine, as soon as I update, you will know that this is different. And the attacker not having the ability of forging my signature can actually, he cannot do anything, right? So
my concern is not about forging.
Yeah.
My concern is about replay. I'm involved in 3 conversations with you and Nick and Sean.
So
right? and I take a subtree from that has Nick and Sean, and I just invite you to a new conversation. I say, hey, this is with Nick and Sean, and I tell you, look, here's a signed thing, and it was signed by Nick because he was.
So we have an ID for each group. Let's assume for the moment those are guaranteed.
Okay.
I'm just like including that into the signature seems like this would fix this, right?
So basically, all that stuff gets mixed.
Yeah, you want to validate, but
the entire subtree of the people you talk to is mixed in the key derivation. So you would not be able to generate a fresh group with different people and get the same group identifier and same keys. So they would immediately know that it's actually not the same group, and they would immediately know because you have to give the public keys of the people that are in the new group. To get that secret, you immediately know that here is the list. At all times, you basically know the list of people that are in the tree.
Just as a reminder, there's 7 minutes left in the session.
Yeah, so
that's why I'm going so fast. Sorry.
Yeah, I was going to try and wrap up. I think Ecker's argument, I think, is pretty convincing to me that this is not really a useful approach here. That we would do better by doing a kind of state confirmation approach. This thing presumes that you are accepting the adder as your sole source of truth. I think Ecker's approach is probably a little bit more practical in the sense of taking some statement of the state of the group, which we already have several hanging on the protocol. I think Brett has suggested a few more. Like taking that and either confirming it with another member of the group or with some third-party source. I think that is maybe a bit better approach than this signature-based approach. So I think I'm inclined to
completely fine with doing something else. I think this is like heavyweight in some sense.
Yeah.
And if we can have like a few non-adversarial members of the tree to confirm the current state, it's fine. It's enough, actually. The question is, how many members do you need to be able to get this public tree, to agree on this public tree? Because, I mean, in the setting where you don't care about adversarial members at all, you don't care. But in that scenario, the group might be small and the attacker might collude with other keys and other parties within the group. And as soon as you have adversarial parties in group, anyway, it gets messy. So this alternative would be fine, I think, to just ask explicitly the other people in the tree to acknowledge the fact that the public tree that you received as a new member is the one that they have as well. Yeah. I think we're done. Yep, good.
Okay, so the next piece on the agenda is interim planning. And so we are going to be putting together a doodle poll and sharing it on the list. Our current idea is sometime in September in London, which is a nexus of several of the developers. This would be a one-day interim. The last interim we had was very productive, and having a small group in a room really iterate on some of these problems was helpful. And so keep your eyes open on the list, and we will try to facilitate a time that as many people as possible can come together.
Do we think that one day is enough, or it gets so productive in those days that actually 1 day and a half or 2 days might actually be. I mean,
well,
I don't care.
It could be the case. Yes,
it's fine for me. But
so we'll talk to the working group and whatever consensus is around how much time we need. I think 2 days or 1.5 is a possibility, but it really depends on how many topics we have and whether or not the presenters share them with the chairs as early as possible so that we can help. Yeah. We need a sense of what actually needs to be talked about. And we do have quite a few issues, as well as the authors have been doing a good job tracking milestones on GitHub. So take a look at the open issues, and we'll discuss whether or not 1 or 2 days is necessary.
Can we get that poll sent out as soon as possible, just for those of us who have to plan in advance and don't have a 2-week notification this time?
Yep, we'll send out the poll either today or early next week.
So I mean, so to be official, have an official meeting where we're going to meet in person, we have to give 4 weeks notice. So what I'm doing right now is trying to see if the authors can tell me when they're available, and we'll work from there, because it'd be weird to have a meeting where none of them could show up. So that's the triage of how we're doing, but we're definitely going to get you guys the info as soon as possible. Thanks. And I believe that concludes the meeting. Thank you very much. If you want to correct that sign of the sheet, the easiest thing to do might be to go to the secretariat and ask them who the sheets have left. The other thing you could do is just send an email.